Hello viewers, in today's class we are going to solve one important definite integral in which greatest integer function is involved, right? So here we have to integrate this function log of greatest integer e raised to x minus 1 from log of 2 to log of 5, right? So here ln denotes the natural log, and we have to evaluate this definite integral where the lower limit is log of 2 and the upper limit is log of 5, and this denotes the greatest integer function, right? So let us start. So let us first denote this integral by the letter I, and let us make use of the substitution method, and let us substitute t is equal to e raised to x minus 1, right? So here we are changing the variable x to t, and t is equal to e raised to x minus 1, right? So dt is equal to e raised to x dx, right? Now from here e raised to x is equal to 1 plus t, so dx is now equal to dt over e raised to x, that is dt over 1 plus t, right? So dx is equal to dt over 1 plus t, right? Now let us change the limits. So here we have the limits from x is equal to log of 2, this is the natural log, and here we have x is equal to natural log of 5, right? So when x is log of 2, then the value of t is equal to e raised to log of 2 minus 1, and when x is equal to natural log of 5, then t is e raised to log of 5 minus 1, right? Now here we'll make use of an important result which says that e raised to log of p is equal to p, right? So e raised to natural log of p is equal to p. So here e raised to log of 2 is 2 minus 1, that is 1, and here e raised to log of 5 is equal to 5, and here we have minus 1, that is equal to 4, right? So when x changes from log of 2 to log of 5, then t changes from 1 to 4, right? Okay, so now let us express this integral in terms of t. So now we can write I is equal to integral from t is equal to 1 to 4, and here we have log of greatest integer t, because e raised to x minus 1 is t, and for dx we can write dt over 1 plus t, right? So now we can write it as t is equal to 1 to 4 log of t, greatest integer t, over t plus 1 dt, right? So now our aim is to evaluate this integral, and here we see that the limits are from t is equal to 1 to t is equal to 4, and between 1 and 4 we have two integers. The first one is 2 and the other one is 3, right? So what we will do, we'll split this integral into the sum of three integrals. The first one is from 1 to 2, the second one is from 2 to 3, and the third one is from 3 to 4, right? So now we can write it as 1 to 2 log of greatest integer t over t plus 1 dt, then from 2 to 3 log of greatest integer t over t plus 1 dt, and plus 3 to 4 and log of greatest integer t over t plus 1 dt, right? Okay, so now our aim is to evaluate these three integrals, and before evaluating these three integrals, let us make use of the definition of greatest integer function. So here we have the greatest integer t, and the value of t varies from 1 to 2, 2 to 3, and 3 to 4, right? So when t lies between 1 and 2, then the value of greatest integer t is 1, and when the value of t lies between 2 and 3, then the value of greatest integer t is 2, and when the value of t lies between 3 and 4, then the value of greatest integer t lies between or equal to 3, right? Okay, so now when t varies from 1 to 2, that is 1 to 2, then the value of greatest integer t is 1. So here we'll have 1. When t varies from 2 to 3, then the value of greatest integer t is 2. So here we'll have 2, and when the value of t varies from 3 to 4, then the value of greatest integer t is 3. So here we'll have 3, right? So now these three integrals can be written as I is equal to 1 to 2, and log of greatest integer t can be written as log of 1 over t plus 1 dt, right? Because greatest integer t is equal to 1 when t varies from 1 to 2, and similar argument goes for these two, right? So similarly from 2 to 3 log of 2 divided by t plus 1 dt, and here we have the integral from 3 to 4 and log of 3 divided by t plus 1 dt, right? So now here we know that the value of log of 1 is 0. So here the value of log of 1 is 0, so the value of this integral is 0, and plus, and here we can take log of 2 outside the integral. So we have a log of 2 and integral from 2 to 3 dt over t plus 1, right? And similarly here also we can take log of 3 outside the integral, and we have the limits from 3 to 4 and dt over t plus 1, right? Okay, now we know that the integral of dx over x plus a is equal to log of x plus a, and we'll apply this formula to evaluate these two integrals, right? So now we can write I is equal to log of 2, and here we have log of t plus 1, the limits are from 2 to 3, and here we have log of 3, and the limits are from 3 to 4, and the integral of 1 over t plus 1 is log of t plus 1, and here we have 3 to 4, right? Okay, so now we can substitute the value of the limits here, and we'll take the difference. So I is equal to log of 2, and here we have log of 3 plus 1 4 minus log of 2 plus 1 3, and here we have log of 3, and putting 4 here, so 4 plus 1 5, so log of 5 minus log of 3 plus 1, that is 4, right? So now we can further simplify it by writing log of 2 times this can be written as log of 4 over 3 by making use of the properties of log, because we know that log of m minus log of p is equal to log of m over p, and similarly here we can write log of 3 times log of 5 over 4, right? Okay, so now we can further write this expression as log of 4 over 3 raised to log of 2 plus log of 5 over 4 raised to log of 3, right? So here also we have made use of the properties of log, which says that if we have a log p, then we can write it as log of p raised to a, right? Okay, so now either we can leave this expression as such, or we can further write it as I is equal to log of 4 over 3 raised to log of 2 times 5 over 4 raised to log of 3, right? So this is the final result for this integral, and here again we have used one important property of log, that is log of p raised to a plus log of q raised to b is equal to log of p raised to a multiplied q raised to b, right? So this is the final result for this integral, right?